Welcome to the second video in our online series on statistical analysis. Today's video will be on the second of the central tendencies, and this particular central tendency is known as the mean of a set of data. To begin, the mean of a set of data is known as the arithmetic average of our data. And the reason why it's referred to as the arithmetic average is because the mean, unlike the median, involves the physical numbers of each of our terms, and is therefore using them to find the sum of those terms and then to divide it by the total number of terms, which allows us to find its arithmetic average. In short, to find the mean of a set of data, for example, 6, 7, 8, 9, and 10, as I said, you need to apply the arithmetic by adding up each of those terms. So if we add 6 plus 7 plus 8 plus 9 plus 10, that gives us a grand total of 40. And then we need to divide that by the number of terms that we have. So since we have 5 terms, we need to divide this by 5, which gives us that our mean is going to be 8. Now what may be new for a few of you is the Greek prefix that refers to mean, and that is the Greek letter mu, which looks like the letter U with this kind of line extending it from it on the left-hand side. And please be familiar with that because all of our quizzes and tests moving forward will be using the Greek letter mu to represent the mean. But to recap, the arithmetic average involves taking all of our numbers, adding them together, and then dividing them by the number of terms to find the arithmetic center of our data. Now, to compare and contrast mean to median, which we covered yesterday, both sets of data have percentages that will differentiate away from its central tendency. In regards to median, the median had the quartiles that split it away from its median, and those were in intervals of 25%. Mean, on the other hand, has a way to differentiate it, but its difference involves something called standard deviation. Standard deviation should be a new topic for all of you. Those of you who have seen it before, please note that we will be calculating this by hand and by calculator, so you need to be familiar with both practices. But what standard deviation represents is the percentage differentiation away from the mean. Now, when we're looking at a graphical representation of data about its mean, similar to when we involve something involving a median, we have our central location of data. But what happens is all data should follow something known as the bell curve, where most of the data, based on just the volume underneath the curve, is found in the central location around the mean. Now what our standard deviations are is spaces that are counted away from our data, which will each in their own outright represent a decreasing amount of percentage of area underneath the curve, and therefore a decreasing percentage of data that is involved within that standard deviation. To calculate standard deviation is a little bit more in depth as compared to finding the quartiles involving the median. Just like the mean requires a little bit more work to find its central tendency, standard deviations will require a little bit more work to find it as a physical value. The steps to find standard deviation are as follows. Step 1 is to find the mean of your data. Step 2 is to find the difference of your data from the mean. In other words, just subtract. Step 3 is you need to square those differences. Step 4 is you need to find the arithmetic average. That is not how you spell average. Of those squares. And then the last step is to take the square root. Square root the arithmetic average. So what I'll do is I will color code each of these, just like we do in class. And we will have an example occurring on the left-hand side. All right, so just to make it easier for ourselves, let's use the same data we used for our initial example. So we'll use the numbers 6, 7, 8, 9, and 10. The reason why I like using those numbers right now is we already know what the mean is going to be for that data, and we know that the mean is going to be 8. So the first thing we need to do is we need to find the mean, which is once again is found by adding up all those terms and dividing by the number. That gave us 8. For the second step, where we need to find the differences of the data from the mean, all we need to do is physically subtract 8 from each of our numbers. So if we do 6 minus 8, that will give us a negative 2. If we do 7 minus 8, gives us a negative 1. 8 minus 8 is 0. 9 minus 8 is 1. 10 minus 8 is 2. Our next step will be to square each of those numbers. So if I square each number respectively, I will receive 4, 1, 0, 1, and 4. The next thing to do is to find the arithmetic average of those terms. So just like finding the mean of our original data, we're now finding the mean of each of those squares. So we need to add each of those numbers up. And we need to divide it by our number of terms, which is 5. So 4 plus 1 plus 1 plus 4 is 10. And then 10 divided by 5 gives us that our arithmetic average of those squares is going to be 2. And to wrap this up, our final step is to take the square root of that number 2, which is 1.414, and that will be our final answer for standard deviation. As a quick note, when you're solving these, standard deviation should be a messier number. Because of how the data will vary in accordance to the bell curve shape, those numbers will not be occurring in nice pretty intervals like it was occurring for the median. So because that, be aware that sometimes your square roots and your terms involving your standard deviation could be rather messy. To give ourselves another example of practicing standard deviation, let's copy down all of our steps. And let's try this with a new, slightly more chaotic collection of data, once again to drive home our point about how these numbers can rather get crazy. So let's choose the numbers. Let's try a 7, maybe 11, 21, 34, and I don't know, 102. So the first thing we need to do is we need to find out what is going to be the mean of each of those numbers. So to find the mean of our numbers, we do 7 plus 11 plus 21 plus 34 plus 102 divided by the number of terms, and we got lucky this time. We found out that the mean is going to be 35. Our second step after finding the mean is to subtract each of those numbers from the mean, or the mean from each of those numbers. It does not matter which term you subtract from which, because in the end we will be squaring, so the negatives will disappear. But I will be doing primarily the top number minus the average, and that will give me negative 28, followed by a negative 24, followed by negative 14, negative 1, and positive 67. From there, we need to square each of our terms. So if I do 28 squared, I get 784. 24 squared is 576. 14 squared is 196. 1 squared is 1. And 67 squared is 4,489. With each of those 5 numbers, we need to find its arithmetic average, which involves us adding up each of those squares and dividing it by the number of terms that we have, which is 5. So if we do 784 plus 576 plus 196 plus 1 plus 4,489, and we divide that by 5, we should be getting 1,209.2 as our term. Now, as a quick note, we will not be covering this in this class, but in AP Statistics, you guys will find out that this term right here is known as the variance. Again, this will not be used in this class, but if you guys go on to take AP Statistics or Statistics in college, just note that that number is known as the variance. Our last step is then to take the square root of that term. So we need to take the square root of 1,209.2. And when we do this, we receive that our standard deviation for our data is going to be 34.774. Now, moving on from here, the way we would graphically represent this, similar to how there's a box and whisker to represent the median as a central tendency for data. For the mean, we're going to draw something called the bell curve. And for a bell curve, it's going to start with the same number line that we began with for a median. We begin by marking where is our mean in the center. And then from there, we're going to sketch a bell curve shape above the number line. From there, you need to draw a total of 3 standard deviations to the left and to the right of your data. So what that means is you need to draw 3 lines going to the left. You need to draw 3 lines going to the right. And all that's left to do then is to find what are the values that represent each of those standard deviations. The way we go about finding those is each of those boxes refers to a counting number of standard deviations above the mean or a counting number of standard deviations below the mean. So to find those values, all we need to do is add our standard deviation to our mean. So once again, going back to our calculator, if we take our mean, which was 35, plus 1 standard deviation, which is 34.774, we can find out that this will be a value of 69.774. But in the interest of time of making this easier for right now, let's say our standard deviation is 35. And in doing so, we can type in 35 plus 35, which will give us 70 as our first marker, and then 105 as our second, and then 140 as our third, as we count. Going in the opposite direction, we will do 35 minus 35, which will be 0. Minus 35 again will be a negative 35. And minus 35 again will be a negative 70. Which will give us, when we're all said and done, the following as our bell curve representation of the data, with a mean of 35, a standard deviation of rounded to 35, and counting up and down for a total of 3 times the following values. Just so you know, it is okay to have negative numbers as a result of standard deviation, because the reason why this is occurring is if we were to plot our 5 data points actually on our graph, we would have a point approximately here, a point approximately here, a point approximately here, a point approximately here, and then our last data point is all the way over here. So with all those data points drawn, you'll notice that the graph needs to have an equal amount of data represented on each side, and this seems to be very bottom heavy for our data. And this one outlier is drastically affecting the rest of the graph. Whereas a median would almost ignore that entirely. We'll notice that when we draw a mean and a bell curve, it is greatly affected by it. So in summary, when we refer to the mean is the arithmetic average of our data, and it is separated by standard deviations away from the mean, which are calculated in accordance to how we did our notes, where we find the mean of the data, the difference from the mean, we square those differences, we find the arithmetic average of those squares, and then we take the square root of that arithmetic average to find our standard deviation. To plot it, just like we did with the median, we plot our central tendency first, but instead of drawing a box and whisker, we draw a bell curve, and then we count out standard deviations away from the mean, and that allows us to plot our 3 standard deviations accordingly. If we scroll past the test question for right now and go to the homework for our section, there is a small collection of data, each of them with not too many data points. Please take a few moments and solve for each of the standard deviations and means for these. You do not need to plot them on the number lines at this time. In the next video, I'll be showing how to solve all this with a calculator, but it is good practice that before you've watched that video on that lesson, then you know how to solve these by hand, because this will be on an upcoming quiz and our test. Thank you, and I will see you in the next video.